Hey guys, my name is Hamjung-hye, and today I'll be sharing the solutions for homework 6. In problem 1, we implement the downscale function to construct an image pyramid from the input image. First, we downscale the camera intrinsics. Both the focal length and the principal point are carefully rescaled to remain consistent with the new image resolution. Next, the intensity image is downscaled by averaging each 2 by 2 pixel block. For the depth map, we also downscale using a 2 by 2 neighborhood, but we only average valid depth values. In problem 2, we implement a function that computes the per pixel photometric residual given an assumed relative camera pose. First, we prepare the pose and coordinate transforms required before back projecting pixels into 3D space. For each pixel in the reference image, we first interpret its pixel coordinates correctly. Using the depth value, the pixel is back projected into the 3D space. The 3D points is then transformed by applying the current pose estimate and projected onto the second image. If the depth is valid and the projected point lies in front of the camera, we sample the intensity of the second image using interpolation. Problem 3, we implement a function to compute the Jacobian using numerical differentiation. We slightly perturb the current pose among each of the 6 motion directions using left multiplicative perturbation on SV3 and observe how the residual changes. Problem 4, we minimize the photometric error using the Gaussian-Newton algorithm. At each iteration, we compute the Jacobian of the residuals and will solve a linear least squares problem to obtain a pose increment. This increment represents the direction that most effectively reduces the photometric error. The update is applied on SV3 using a left multiplicative formulation to ensure the geometrically valid pose update. We repeat this process iteratively until the error converges. In problem 5, we implement an analytic Jacobian for faster optimization. We first compute the image gradient in the x and y directions and interpolate them in the warped pixel locations. Then using the chain rule, we combine the image gradient with the derivative of the projection and SV3 motion model. This directly gives us the Jacobian of the photometric residual with respect to the 6 pose parameters.